All right. So yeah, that question again. Did I answer your question right? Did I hear you correctly about when you're trying to find a relationship between two variables, say X, Y? Um, you've noticed that in the table where you look at the critical values, depending on the size of your data, of your paired data, like if we're talking about, let's say we wanted to see if there's a relationship between the weight of a bear and the size of its chest. So in one variable, we'll have a bunch of bears' weights, and then linked to every bear, let's say we have their chest size. We measure around their chest. And if we only have, say, 8 bears in our sample, which is relatively small, we're going to have a very strong relationship in order to show that there is a relationship between them, because the sample size, again, there's just a lot of missing information. And versus if we have a larger group. Have you had some theories about this yourself?
Yeah, I was thinking because whenever there's a big data set, it's more scattered than if you just had like a few data points.
Yeah, I agree with you. I like that. So I guess we're kind of saying the same thing, right? And was there a problem that came to mind that made you was there a problem that came to mind when you were asking when you thought about that question?
I don't think so.
Okay. Yeah, I've had a few people ask me about how are we comparing the R, like why are we making the decision? Where did these numbers come from? And they didn't check the table. I know that's not you, but there were some students who didn't realize that you have to check the table and compare your R value with the one on the table to make a decision whether or not there's a relationship or whether or not there's not a relationship. And depending on, again, the size of the data, that'll let us know on the table which row we're going to use, which values we're going to pick. And there is a relationship between the size and the correlation coefficient. What's needed, what's required in order. It has to pass that critical value in order to determine if there's actually a relationship between them. And then we also have to analyze the graphs, because often there could, even though the data works out that there's a relationship, we have to also spot check the graph and make sure that the graph is some kind of linear formation, um, because there's potential, um, there. Yeah, I've seen other situations where you might have that relationship, but they never checked the graph and something weird was happening with the graph. Um, but yeah, I mean, you got to have a nice random sample there, and the bigger we have our sample, the more likely our results will be more conclusive. Um, and of course, yeah, they definitely will be more scattered as well. um, so did you want to hop to another question, or do you want me to talk a little bit about the midterm as well? So one of the things we were going to talk about was the format of the test, and it's it's pretty cut and dry. And I'll just for the record, I'm going to let everyone know how much time they'll have, and I'm going to pull up some information about the midterm, and then we're going to get back to answering some questions. And I want to make sure that we feel really good about everything. All right, so and I'm going to probably, let me see if I can find a place where I can write about the midterm. I'll probably end up sharing my screen is what I'm thinking of doing. So do you like stats so far?
Yeah.
Cool. Yeah, there's a lot of different stats classes, and the cool thing is that there is stats is starting to well, the artificial intelligence, when you talk about technology, because that's really what's happening right now, is AI is becoming a very huge deal. Oh wow, I didn't realize that there's only 15 questions on it. Okay, that's good to know.
Is the midterm covering sections 1 through 5?
Yes. So and that's exactly what I want to talk about. So I'm going to share my screen real quick, and let's just get very let me uh point out exactly what you're talking about there. That's good. So let me hide my task. All right. So again, our midterm is um whoa, that's a squiggly eye. It almost looks like an S. Excuse me. It's on the 25th of October um through, so it opens Wednesday, and that's right at the stroke of midnight, and closes Thursday at 11:59 p.m. All right, I got to make sure my writing is a little clearer. So it's a little wow, it needs some work right now. All right. Um it's uh open for 48 hours, and you have to take it within that time frame. I will not really extend the midterm. It's just one of those things where you have to take it, otherwise you miss it. It is 25% of your grade, which is outlined in the syllabus, and it turns out to be 15 questions. And I'm going to list the sections that those questions come from. I think that that's good information. I usually do that, and I'll do it here as well. I see 1.1, 1.1, 1.2, 1.2, 2.1, 2.2, 2.2, 2.4. There's also a 3.1, a 5.2, 5.3, 1.3, 3.4, 5.1, and then also a 3.5. So that should be 15 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the 15 questions are coming from a mix between chapters 1, 2, a little bit of 3. We don't see 4 on there, which is just the way it is. And then 5. 3 questions from 5, 5.1, 5.2, 5.3. I could have listed the I could have created a stem plot. I could have did a 1, 1, 2, 2, 3. That's 5 questions from chapter 1. And then 1, 2, 2, 4. That's another 4, so that's 9. 3, we have just 1, 4, and 5. Nothing from 4. And then 1, 2, 3. And I think this covers it. Yeah, that looks like it's 15 in total. And so there's my stem plot. The chunk of the distribution of this, it's skewed. The majority of the questions are coming from 1, 2, and 3. And again, a question from 5.1, 5.2, 5.3. So you don't have to study too much in chapter 4, but it could pop up on the final exam. The final exam is going to be cumulative. The final exam is going to have questions from 1 through 11, but most of the questions will come from 6 through 11, most of them. There might be a few questions on the final. We'll talk about that when that time comes, but there might be a few questions from them, but the majority of the questions are going to come from the second half of the course.
Okay.
So that's the format. That's what you could expect. As far as the time, there's going to be an abundance of time, 150 minutes. All right, that is 10 minutes per problem potentially on average, and that is just 2 hours and 30 minutes as well. Now, if there is a technical difficulty and a glitch or something weird happens, message me. I think if you were to close the window or go out, you might get locked out. You might not be able to enter it again unless you message me and I will enable access again. StatCrunch will be a learning aid. You can click as you're taking the test, you will have access to StatCrunch and you will have access to the textbook. Those are the only aids that will be permissible as you take the test while you're taking the test. The learning aids is the textbook and also StatCrunch. There won't be like Ask My Instructor or anything like that. So you'll just go on. It honestly, will probably take less than 40 minutes to complete the test. But there are some individuals who qualify for additional time and certain accommodations, and I want to make sure that everybody is fair and everyone has an opportunity to feel comfortable with the amount of time. But I don't expect anyone to take more than an hour. Although you can if you want. It's not gonna hurt if you do, but it's uh, I wouldn't expect it to be an hour and 50-minute long test. I just give this time just to so that it's fair for everybody. I want everybody to feel comfortable and ready for the test. You have 10 minutes per problem on average.
Okay. So I think I had another question I wanted to ask you.
Yeah, please. What's up?
It's on the calculator. Could I share my screen?
All right, give me one moment. I'm gonna make you the co-host. You're now co-host, so you should be able to share.
Okay.
Here, I'll stop. So your calc.
Can you see it?
Yes.
So, in your lecture, you went to the tests, and then you picked this one.
Linear regression t-test.
Yeah.
Yeah,
And
yeah.
then you hit calculate, and then you said something about how if the p-value was less than 5%, then the line was a good fit.
Usually, yes.
Well, my question was like, what does the p-value like mean? And is there a formula to calculate it?
Yes, and that's actually something that we'll be talking about later. We're going to spend a great deal of time talking about the p-value when we get into hypothesis testing. So right now your p-value is extremely small. That's scientific notation. Do you see that little e -5 at the end?
Yeah,
Yeah, so that means times 10 to the -5 power.
yeah,
So it's really the real number of your p-value is 0.00002879. You knew that, right? Did you know that?
yeah,
You noticed that?
yeah.
Um, and it looks like you only have your degree of freedom is 5, so you probably will have 6 values in your data set. And so so basically the two variables, list 1 and list 2, are very, very correlated. I don't even have to check a table because the p-value lets me know whenever the p-value is extremely small, um, we reject the null hypothesis, um, and it's sometimes it's a huge test that will take. And I use the linear regression, but there's other ways to get certain things. It just really depends on the question that they're asking, but we will be talking about it, and there is a formula to calculate the p-value. Once you get the test statistic, that t, the next step is to get the p-value, and and it's a huge deal to calculate it. We will be doing that quite a bit in chapters, especially chapters like 8, 9, and 10.
Okay. Well, how is using the p-value different from just using the correlation coefficient?
It's it's all pretty much the same thing. But if you keep scrolling down, what else are they giving you on that? So they actually are giving you the 0.98 thing, the correlation coefficient, but the p-value is when there's an actual test involved, and we're trying to determine whether or not a regression line is a good model. It's it's similar to the correlation coefficient for sure. It is, but it tells you different things, and it really just depends on the question that we're working on. But it seems to me that I don't know if there's any questions where they'll require you to do that. And keep in mind, and a lot of statistics classes are very different from each other. That's the thing when I say statistics is like making spaghetti, because everybody has a different version of spaghetti. Like if you go to your friend's house and have their spaghetti, it may taste very different from the spaghetti that your parents make, or the spaghetti that you get in the restaurant. And if you decide to go to another restaurant and you want to try some spaghetti, it's going to be different, because everybody likes to customize it and put their own taste to it. And that's exactly like statistics. Statistics is that course where people will customize it and make it their own in a way. It's kind of a, there are some things that will always be common to each statistics class, but there will be some differences as well. And sometimes the differences is in how they go about conducting tests, and which variables they're using as well. And so sometimes when we use our technology, the calculator will just spit out so much information, and we may only need like a part of it, a piece of it, but we don't need it all. And so that's kind of something that we should be aware of.
Okay.
So another thing too I wanted to show everyone is that the practice final, I mean, sorry, practice, I say final, I meant practice midterm. Let me go there for a second there. Let's see. So I think it's a lot of people. So it's okay if you want to work on the practice midterm after it closes out. The only thing is you're going to have to print it out on your own, because it's going to close out right before the real test opens. So the practice midterm is only going to be open for one more day. And the questions on it, there's just so many questions. There's 50 different questions. Obviously, it's more than enough. And nobody's getting graded on this either. I put 99 attempts, 600 minutes. I just wanted it to be available so that people can try it over and over again. But if you do take it, there is a way to do these questions and then print it out with the answers as well. So here at the bottom, you have the different learning aids. It shows you the time remaining as you're taking it. This will be just like the test. The only difference is we'll have 15 questions instead of 50. And as you go through them and start matching things up, you could you can then print it with the answers, and that's pretty helpful, and study from that as well. So that's kind of a workaround that can help many people as they're preparing for the test. So like if I tried to match these, this is like something where I have to go through and match it with the words like continuous variable, qualitative variable, the characteristics of individuals within the population. Well, characteristics, I would say that's maybe qualitative. I'll just try this real quick. I don't know. I mean, let's see, provide numerical measures of individuals. The measures can be added, subtracted, and provide meaningful results. I'll say continuous. I may change my answers around. Information that describes the characteristics. I think allow for classification of individuals based on some attribute or characteristic. I think I'm going to go with and then I'm going to go here, and then discrete has a continuous would be there. Discrete. No, that's discrete. And then quantitative. Um, hmm.
Yeah, I think that's it.
Okay. Yeah, I think so too. I wasn't quite sure, but I'm just gonna hit next. And blank is a person or object that is a member of a population being studied. Well, it's not a sample. Um, I like individual here. Statistic as if we were dealing with a sample, and it's some type of proportion there. I'm gonna go with individual. I could be wrong. What do you think? That seemed about right, huh? Let's see. Determine whether the underlying numerical value is a parameter or a statistic. This is from chapter 1. For certain movies, 64% of 112 members of the audience were females. Well, if we're talking about the audience, of the 112 members of the audience, wait, okay, for a certain movie, 64.3% of the 112 members of the audiences were females. All right. So to me, the entire population was 112. Um, So something tells me that it's a parameter because the data set of 112. I like E. I could be wrong. Some of these, I mean, you just never know. All right. So let's just say, all right, I'm done. I want to submit my test. So this is what you do to get it to print the answers. And I'm going to get to your question in just a moment. Okay, yeah, wait. Rian, yes, you have your hand up.
Yeah, I had a question.
Okay.
So how do you know that one box plot has more dispersion than the other box plot? Like, is it based on range or interquartile range?
Um, that's a great question. Do you is there an example somewhere that you see, or is this just a question in general?
Yeah, I got a question on one of the homeworks where two of the options were the same, except one of them said it was because of the range, and the other one said it was because of the interquartile range.
Okay, I'd have to look at that question to see, because sometimes they're sneaky. Like sometimes the numerical line underneath the box plot could be different, and it could change, and that will change our answer if the numbers underneath the box plot are different. But if they're the same for every box plot, I would definitely look at the minimum and the maximum, and whichever one is longer, because that's going to let you know that you're dealing with a longer amount. But again, I'd have to try to find that question and take a look at it because I'm not sure there. Okay. Does that kind of make sense? Um, so here I'm going to submit this. I'm going to choose yes. All right. Submit. Yes. Submit. Okay. So I got 3 out of the 50 questions right. Um, so I did get all 3 of those right because I didn't do 4. I don't think I attempted 4 at all. Yeah, we just did 3, but at 4 I didn't answer. Um, so I'm gonna go back, and this is where well, I'm gonna make sure that I can print the test. So it says review test, but where I hit review, I hit print, and then it says print this question or print test with correct answers and your answers. So I'm going to choose print test with correct answers and my answers. And now I'm going to print it to a PDF. This is taking a long time to render. I have some choices on how I want to print it. I could use, whatever. I'm going to choose PDF and then hit print. Well, excuse me. All right. And what was that? Oh my God. I can't even move it. All right. I'm gonna have to edit that out because it's showing a lot of sensitive information. This is a recording that everyone's going to be able to see one day. Anyway, um, So now that I printed it, all I got to do now is just find it. Sometimes I print to OneNote. All right. So now I have a PDF of this, and this can help me as I'm studying, right? I could start to print this out or just keep it on my computer. As I go through the problems, I can kind of see what I got right, what I got wrong. You can start to go through some of those questions. Like here's a question about box plots. Zoom in on this. It says, which of the accompanying box plots likely has the data with the larger standard deviation, and then why? And remember, standard deviation measures the variation of the data. How spread out is it? So how much does it vary? Or are the numbers really close to the mean? So the standard deviation lets us know this. Like if our standard deviation is high, that'll let us know we have a lot of data that's far away from the mean. If our standard deviation is very low, a lot of our data is very close to the mean. So the standard deviation can help us make predictions. And when we start using probability, it can help us answer certain questions about what the data can tell us if we understand the value of the standard deviation. Now, out of the two box plots, I like that two. The second one, to me, feels like the data is going to be more spread out. But the lower 25% of the first one is going to be more spread out than the lower 25% of the second one. But the upper 75%, the top 25% of all the data, I don't know how many data values are in there. Let's assume 100 in each. If there was 100 in each, the top 25 will be more spread out than the top 25 here. But I'm going to make my answer be 2 because I feel like, oh, and that's what they say here too. I didn't look at the answer, but I was going to say because the inner quartile range, which is half of the data, is much greater than the 50%, the inner 50% of the first one. So they actually said box 2 is likely to have a larger standard deviation because the box plot appears to have a greater spread, which likely results in a larger standard deviation. It's just likely, right? This is not an exact science. There can be errors. And that's the nature of statistics and even when you're talking about artificial intelligence and all of these things, there's still bias, there's still error, a small percentage. But we could say with a high degree of certainty that 2 is more likely. Okay, but that wasn't even your question, because your question was a little different from that one. Any questions about that?
No.
Nice.
Actually, I have one more question I wanted to ask you.
Sure.
So, in your lecture, you said that using R squared gave you a lot of information, but I was wondering, like, um, why use the value of r squared instead of just r? And like, what was the original reason for squaring r?
Yeah, that's a very tough question, because well, r does a lot, right? We already know that r is going to be between -1 and 1. If r is positive, that lets us know that we're dealing with a positive relationship. If r is negative, we're dealing with a negative relationship. But when we actually square r, we're now talking about a percentage of um it lets us know how well our regression line is predicting the actual values, the differences between the actual values. So it's the percent of variation that is explained by the y coordinate. And so if our r squared is high, like 90%, that lets us know that 90% of the data is being explained by our regression line. So it's that type of thing. It's a different type of question, but it doesn't do what R does. R does its own thing, and R squared tells us something totally different. So R squared is obviously, it's easy to calculate once you have R, but interpreting that value is totally different from R, because R is not a percentage, but R squared is. And the exact definition of R squared, and I mean, we could pull it up in the book here. Hopefully my book opens. And this is from is this from chapter 5 or chapter, I'm trying to see where, I forget what chapter they talk about R squared in.
I think it was in chapter 3 or 4.
Okay, so yeah, I just don't, for some reason it doesn't have the table of contents. I'm not seeing that, which is really awkward because, oh wait, here we go. What? Yeah, I'm not. It's really odd. Because it would be hard for me to, I mean, I guess I could just try to. All right, you know what? Hold on. That's, I know where to go. We could just go to, um, we can come here. I'm going to download this. I probably already have it downloaded, but let's pull up the textbook real quick, just so we can get the right language. Um, so here they're explaining how to calculate the R. Let me see here, hold on. R squared. Yeah, I may have to all right, 1 second. So we have R. So R is a pretty big formula to calculate. That's why we usually just use technology. So since R is here, R is first introduced here as the linear correlation coefficient. The sum of the difference of this times that divided by its standard deviations, and then divide all of that by n minus 1. But there should be a definition that talks about R squared that we can look at real quick. Let's see, 1 second. Yeah, it's in one of these sections. It seems like they didn't talk about it all that much, but I mean, if I go to the glossary, and we see R, let's see, hold on, I have ABCD of change. So correlation, yeah, let's see, hold on. CO, um, yeah, let me get the, I'm gonna check the full name of. It's the coefficient of determination. All right, 1 second. Let's see if we can find that. Two 11. So it was under the diagnostics of the least regression line. So when you're examining the least regression line, so that when the diagnostic, sometimes we have to assess it and figure out if it is a good measurement. So here, the coefficient of determination R squared measures the proportion of total variation in the response variable. This is the Y value that is explained by the least squares regression line. And so they go on and talk a little bit more about it. But it gives us a percentage, and that percent lets us know how much variability in the y is explained by the least squares regression line. It lets us know how good our line is for accounting for the variation. And here's like 3 examples. In data set A, as you can see, that scatter plot is right on. And that's like a perfect linear relationship. The variability is like 99.9%. Our line is a great predictor. So certain values that we don't have, we could use our line to predict what those values could or should have been, and B as well. But then if you look at C, yeah, we got the linear regression line, but the R is so low. And I mean, if you take the square root of that value, you'll have the correlation coefficient, and that's going to be kind of weak as well. You know, be under 0.5.
Well, technically, why would you use r squared? Like, couldn't you also cube the correlation coefficient or like multiply it by a certain number? Like, why specifically r squared?
Yeah, I'd have to look into that. It's I think it really just depends on how the correlation coefficient is I mean, first of all, when you the it's kind of unbiased because you're squaring it. So R could be negative, and R could still have a pretty strong correlation. But the moment you square it, you're now dealing with, it's more robust to square it. So because R is going to go from -1 to 1. If you square -1, you get 1. If you square 1, you get 1, which is 100%. And so here we're using R squared for that reason. It's just more, it's more robust. But I don't think they explain it, and I actually never heard of an explanation on why R squared. I mean, I just think that R squared is going to go from 0 to 1. And I mean, they're kind of selling it here for you. They're saying that the coefficient of determination is a number between 0 and 1, inclusive. So it can include 0 and 1 and everything in between. The least squares regression line has no explanatory value. If R squared is 1, the least squares regression line explains 100% of the variation. So I think we needed it. We needed something to create a percentage from R, and squaring it is just it makes sense. Because if R, the same thing, if R was -1, if we square it, we will get 100%. Okay, that's good.
Okay. I don't have any more questions.
Okay. Nice. Right. Yeah, so if there's not much other questions, we're probably gonna wrap it up for tonight. I didn't get any questions coming in through the chat, but I know a lot of people mentioned that they wanted to hear some of the recordings, and I also know that at some point we were gonna do office hours, and then I think we both forgot about the time, and so we missed it. But if you didn't have any questions from that either, then we'll probably just wrap it up. But yeah, I think the test will probably be pretty easy. All right, don't be surprised if it's easy for you. Um, it seems like both of you all are. Do you guys study together at all?
Yeah, a lot.
Okay, and in all of your classes that you're in.
Yeah.
Are you in some classes that your sister's not in?
No, we're taking the same 3 classes.
Awesome. Yeah, and one thing that's cool, that it would have been nice if because I know you're a computer guy, to learn this program called R. There's a program called R. Have you ever heard of R?
Yeah, I think it's a programming language.
It's it's an open source statistics software program. Yeah. And you can program things, but the whole course could be done in R. Like R will calculate the correlation coefficient of a data set. It's something that data scientists use. So R is another free software. There's also something called um, there's quite a few. Mostly people use Python. Have you heard of Python? Yeah, Python and R um, are really two important tools for data scientists. And there's
Yeah.
a there yeah, so there's a suite that's called Anaconda. And if you download Anaconda, you will have R, you'll have Python, and it will be the latest version of it with all of a lot of packages pre-installed.
Yeah, I used Anaconda before.
Okay. All right. Yeah. So and then Jupyter notebooks. So inside, and same thing with Kaggle. And Kaggle has the notebooks, and Google has them as well. But when it comes to statistics and stuff, have you been using StatCrunch?
Yeah.
Okay. Yeah, StatCrunch is fine too. StatCrunch is our own program here. And what's cool about StatCrunch is it will automatically input the data for you. And that's a lifesaver. Because in the other programs like Python and R, you have to write code to get your to upload your data. That's the first thing you got to do is, well, after you import all your packages that you plan on using, then you have to write a code, some line of code that will then tell you to input your data. But the code, the command to do that is always the same, especially if your data is in a CSV file or an Excel file. But in R, you can even collect data off the internet. You can write code, and you can get data from anywhere, and then you have to put it in the right format And that takes quite a lot of practice to get good at doing that. But it seems like you're going to be learning about that too. I know if if you really like math and you're doing stats, and then you're also going to be doing computer science, it seems to me that at some point you'll probably learn about what data scientists do as well. But yeah.
Okay. So thanks for answering my questions. I'm going to leave now.